Number 34, here's the story. Julie and Eric, they are on their boat, and then they are going 63 miles downstream for 7 hours. And then when they go back up against the current, it took them 9 hours. And we are trying to find out the rate of the current. How fast is the water going? In fact, we have two things that we don't know. We don't know the speed of their boat, and then we also don't know the speed of the current, the speed of the water. How fast is the water going? So I will begin by letting my variable, let me say B equals to the speed of their boat. Okay, how fast is their paddling or things like that. And then I will say C equals to the speed of the current. How fast is the water going? Okay, so these two are my variables. And then in this situation, we have the distance, the time, and the speed. So we have to use that famous formula again. Rate times time is equal to distance. Speed times time is equal to distance. Same thing. I prefer to use the word speed, so let me write this down right here. We know that speed times time will give us the distance. Okay? And then we have two situations here. We have the downstream situation, and we also have the backups, when they go back against the current situation. So let me put this down right here. For the first situation, it's the downstream case, and then the second situation, typically we call this the upstream, when we go up against the current. Okay, so let's play tic-tac-toe right now. Let's draw a tic-tac-toe box like this. We're not going to finish the game, okay, but we are going to fill in the boxes right here. And this is how we are going to do it. Let's think about it. We are going to fill in these boxes, okay? When we go downstream, we have the speed of the boat and also the speed of the current. The water is helping them go faster, because they are going downstream, the water is pushing them down, so they are going faster. So we are just going to add the two speeds together. So for this situation, we have B plus C for the speed when they go downstream. And likewise, when they go up against the current, the water is going to go against them. So they are actually going to go slower. Originally, the speed is B. I have to subtract C, B minus C, because the current, is making them go slower. So we subtract. And then the time. What's the time that they use when they go downstream? It's right here, 7 hours. So I'll just put down 7 right here. How about when they go upstream? The time is 9 hours. Took them 9 hours. So I'll put 9 right here. And we are almost done. What's the distance when they go downstream? Well, that's 63 miles. I'll just put down 63. And then when they go upstream, going back up, it's the same distance. So it's also 63 miles right there. And this is the chart that we need to come up with the system of equation for us. Okay, so now, how are we going to come with the equations? Be careful with this part right here. When we want to find out the speed of the downstream, we have to first add a B plus C. So we technically have to use a parentheses. And all we need to do is just read this across. This part, B plus C in the parentheses, times 7 will give us 63. That will be the first equation. That's it. So let's write it down right here. B plus C in the parentheses times 7 will give us 63. Okay. And then the second equation, it's very similar. We are going to read this across, but then put parentheses around the B minus C. We have to calculate this quantity first. So we have B minus C in the parentheses times 9 equals to 63. That's the second equation. Okay, times 9 is equal to 63. And these are the two equations with two unknowns that we need to solve. Okay, so how do we solve these equations? We have choices. Perhaps the popular method is people like to distribute the 7 into the parentheses and then combine terms and then solve for B or C or things like that. But in this case, we have a parentheses times 7 is equal to 63. What we can do is take a look of the first equation here. I'm going to divide both sides by 7. If I do that, this 7 and this 7 will cancel, and then we will just get, let's see, B plus C equals to, and then It just happened that 63 divided by 7 is a nice number. So this strategy works really well. For the second equation, we have the same situation. Parentheses b minus c times 9 is equal to 63. So we can divide the left hand side by 9 and then also the right hand side by 9. So that the 9 will cancel out. And in this case, we'll get b minus c equals to 63 divided by 9, we have 7. And you see that we can just reduce the numbers right here in the equations. And I'm going to look at these two equations. And very nicely, we have the positive c right here and the minus c right here. If I add this up together, the plus c minus c will cancel each other out. And then what we are going to get is b plus b, which is 2b, and that's going to be 9 plus 7, which is 16. And 2 times b is equal to 16. We can divide both sides by 2. So we can cancel this 2. And what do we get? b, this is my b, equals to 16 over 2. It's equal to 8. This is my b, this is my 8. Okay? Well, what does the b stand for? B is the speed of the boat that they're on. They're riding the boat. But the question is not asking for us for the boat. We're trying to find out the rate of the current. So that's a c value. But let's look at this equation right here. We know that b plus c is equal to 9. But then we know b is equal to 8. So in another word, let me just show you guys all the steps. We know b plus c is equal to 9 in this equation. And b is equal to 8. So I can just plug in 8 into this b. And then that means 8 plus c will give us 9. And of course, to solve for c, we can just subtract 8 on both sides. So we can cancel this out. And then what do we get? Well, c is equal to 9 minus 8, which is 1. C is equal to 1. And that's the rate of the current.